Machine learning is often equated with algorithms. People tend to think of algorithms as the magical core of machine learning, the secret sauce that makes everything work. This is a common misconception. People hear about powerful algorithms like deep neural networks and assume that's all there is to it. But algorithms, while impressive, are just one piece of the puzzle. They are tools, not the entire system. But, honestly, this view is overly simplistic. It's like saying a car is just an engine. Sure, the engine is vital, but without the wheels, the transmission, or the steering, the car wouldn't function. While the engine is crucial, it's only one part of a complex system. Focusing solely on algorithms ignores the bigger picture of machine learning. Data, infrastructure, and human expertise are equally important. It's a bit like fixating on a single ingredient in a recipe and ignoring the cooking process and other components. A recipe might call for salt, but salt alone doesn't make a dish. Just as a delicious meal requires more than just a single ingredient, successful machine learning requires more than just algorithms. It's the synergy of data, computation, and thoughtful design that creates impactful solutions. Machine learning is, well, an intricate ecosystem with interconnected components. Each component plays a vital role in developing and deploying effective machine learning models. Data acts as the foundation, providing the raw material for learning. Algorithms are the tools used to process this data and extract meaningful patterns. The training process is where the magic happens, as algorithms learn from the data. Evaluation and validation ensure the model's performance meets the desired standards. And finally, deployment brings the trained model to the real world, where it can make predictions and decisions. Data is the lifeblood of machine learning. It's the raw material that algorithms use to learn and make predictions. Imagine trying to bake a cake without ingredients. That's what it's like trying to do machine learning without data. The quality and quantity of data directly impact the performance of a machine learning model. High-quality data relevant to the task at hand is crucial for accurate predictions. Data preparation, including cleaning, transforming, and selecting relevant features, is a critical step in the machine learning process. Section 4. Training, shaping intelligence from raw data. This section delves into the fascinating process of transforming raw data into actionable intelligence through training. It's a critical step in the journey of machine learning, where algorithms evolve from simple instructions to powerful tools capable of solving complex problems. Training is where the algorithm learns from the data. It's a meticulous process that involves feeding the system with vast amounts of information, allowing it to uncover hidden patterns and insights. This step is the foundation of building intelligent systems. It's kind of like teaching a child to ride a bike. At first, they might struggle, but with consistent guidance and practice, they gradually improve. The same principle applies to training algorithms. You provide guidance, feedback, and practice until they master the skill. For algorithms, this guidance comes in the form of labeled data and iterative adjustments, ensuring they learn effectively and efficiently. In machine learning, the training process involves feeding the algorithm with data and adjusting its parameters to improve its performance on a specific task. This process is both an art and a science, requiring careful tuning and evaluation. The algorithm learns to identify patterns and relationships within the data, enabling it to make predictions on unseen examples. These predictions are refined over time as the model becomes more adept at understanding the nuances of the data. This iterative process continues until the model achieves a satisfactory level of accuracy. Each iteration brings the model closer to its goal, improving its ability to generalize and perform well on new unseen data. The choice of algorithm and the training process itself significantly influence the final model's effectiveness. Selecting the right approach and fine-tuning the training process can mean the difference between a mediocre model and one that excels in real-world applications. Section 5. Evaluation and validation, ensuring the model delivers. In this section, we'll explore the critical steps that ensure a machine learning model is not just functional, but also effective in real-world scenarios. Once a model is trained, it needs to be evaluated to ensure it generalizes well to new, unseen data. This step is essential because a model that only performs well on training data is of little use in practical applications. This is, well, crucial to avoid overfitting, where the model performs well on the training data but poorly on real-world data. Overfitting can lead to misleading results, making the model unreliable when faced with new challenges. Evaluation involves testing the model on a separate dataset that it hasn't seen during training. This process helps determine how well the model can handle new data. Metrics such as accuracy, precision, and recall are used to assess the model's performance, providing a comprehensive view of its strengths and weaknesses. These metrics are not just numbers. They offer insights into how the model behaves under different conditions, helping data scientists identify areas for improvement. Validation is another crucial step that helps fine-tune the model's hyperparameters and prevent overfitting. By adjusting these parameters, the model can achieve a better balance between complexity and performance, ensuring it remains robust across various datasets. Rigorous evaluation and validation ensure that the model is reliable and makes accurate predictions when deployed in real-world applications. These steps are the foundation of building trust in machine learning systems, enabling them to solve real-world problems effectively and efficiently. Section 6. Deployment, bringing machine learning to life. Deployment is the final step in the machine learning lifecycle. It involves integrating the trained model into a real-world system or application where it can make predictions and decisions. This could involve deploying the model on a web server, mobile device, or embedded system. The deployment process requires careful consideration of factors such as scalability, security, and maintainability. Monitoring the model's performance post-deployment is crucial to ensure it continues to perform well over time. Deploying a machine learning model is like launching a rocket into space. It requires meticulous planning, execution, and ongoing monitoring to ensure success. Section 7. The holistic picture of machine learning. Machine learning is not just about algorithms. It's a holistic process that encompasses data preparation, algorithm selection, training, evaluation, deployment, and ongoing monitoring. Focusing solely on algorithms is like judging a book by its cover. It ignores the rich tapestry of processes and components that contribute to a successful machine learning solution. By understanding the entire machine learning ecosystem, we can develop more effective and impactful applications that solve real-world problems. Remember, machine learning is a powerful tool, but it's only as good as the data it's trained on and the processes used to develop and deploy it.